All right, lecture number 15. Almost the end of the quarter here. All the topics that I did in the first 14 lectures, they kind of apply to almost any kind of app, right? Gestures and animation and persistence with Codable and all these things. Those are things you want to do in almost any app. This is the first time I'm going to cover something that really is only in a certain kind of app, which is a document-oriented app, right? We have emoji art, create these nice emoji art documents. They're truly documents. The user wants to save them and rename them and move them to iCloud Drive and do all this kind of stuff. And that's different than like Memorize. Memorize, it plays a little game, but it doesn't save anything as a document or whatever. So that's what we're talking about today. Before I do that, I'm going to talk just a little tiny bit about app and scene, which we've taken for granted, right? Your little @main program, you have that app thing there. I'm going to talk a little bit, just a tiny bit more about that, but usually you don't need to do much with app and scene. How you've been using it is pretty much how you use it. And after we talk about the document architecture stuff, I'm going to come back and talk about two topics, undo and notifications. Undo, you might be surprised to see here, but it actually, none of that document stuff works without undo. So you have to do undo to make the document stuff work. And then notifications, I only am bringing this up. Notifications really is an old API, and we hardly use it anymore, but there's a couple of places where it's useful, and one of those places happens to be in our emoji app. So I'm going to show it to you really briefly at the end of the slides, and then really at the end of the demo, I'm going to quickly show it to you. It brings up a little bit of a can of worms because it is this older API, but I think in the name of completion, I should show you this thing. So let's talk about app and scene. So app is just a protocol, just like view is a protocol. It seems very similar, actually, when you look at your @main program and you have your emoji art app. It has a var body, just like view has a var body, but the type of the var body in app is some scene, not some view, some scene. So your app is structured as you've got this app, which is this app protocol thing, and then you've got multiple scenes. And the reason you have multiple scenes is because your app can have multiple windows on iPad and on the Mac, right? So on iPad, again, we've started to see a little bit of the multiple window UI. A lot of people don't even know it's there, but it's there. It's pretty cool. And then on the Mac, of course, you can imagine having multiple windows with multiple emoji art documents open. And each of those windows is a scene, capital S scene. It is another little protocol here. So there's not much to say about app except for that it's the thing that decides what scenes you're going to have. Now, what about scene? Let's talk about scene. Scene is a container, a window that contains your top level view. And we've seen this, right? Because we had our Memorize view was the top one, and then we have our emoji art document view. These are views that are at the top level of a scene. So the scene is where you say what that is. Now, you can create your own scenes, like you create your own views, and this is pretty rare. I think one example of where you might want to do this is you want to look at this @environment variable called scene phase. Scene phase tells you things like, this scene has become the foreground scene, or now it's in the background. And you might care and want to do something when that happens. Then you might be creating your own scenes, but normally you're not creating your own scenes. You're using the built-in scene creators. Of course, you know of the one that we've been using so far called Window Group, but there's a couple other ones I'm going to talk about today. So these scene building scenes, Window Group, Document Group, has two versions of it. You can kind of think of these things like for eaches for scenes. A Window Group, so far we had one little view in there and it took over the whole screen, and we didn't create multiple windows, but Window Group can create multiple windows. And I'll show you the UI in emoji art today, how you create multiple windows. And when you create multiple windows, it's just going to create a new container and a new copy of your view. But if you have the same view model that's shared between them, then you're going to be seeing the exact same thing in every one, right? Because of course views are just showing what the view model represents in the model. So you're going to have that. So that may not seem that much, but when you have a document group, you're much more likely to have every scene have its own view model, because each one is representing a document here. Let's talk here about the green content. You see that each of them has this green content. In the Window Group, it's just some view, and that's going to be what fills the entire scene. So it's content view, or Memorize, emoji Memorize game view, or emoji art document view. In the document group ones, you can see that there's an argument there, config in. You see that config in? That config is what tells you which document is going to be opened in that given scene. So this closure, this green closure for the two documents is called with this argument of config. And the config, simple little struct, it basically has two things, I think, the URL of the file and a view model to use. This document group will call that closure every time the user wants a new scene. So window group is the one you've seen before. As I said before, if you have @state object at your app right there, then yes, you can still create multiple windows in the window group thing, but they're all going to be showing the same view model, so they're all going to be exactly the same thing. There's nothing that says, though, you couldn't move that @state object down into the view and then have every window be its own little game, right? Emoji memorize game. You could do that, certainly possible. And that's why it's important to understand @state object scoping. Is this at the app shared overall, or is it in the view only for this view? Now, most of what I'm going to talk about here is the document group. So this document group that you see on here, the code, this is for an editable document, like an emoji art document, where we're going to be setting the background and adding emojis and all that stuff. So let's look at all the parts of this. I've color coded these things here. So the yellow is the actual call to the scene building scene, the for each like scene thing called document group. And you can see it has two arguments actually. Let's look at the second argument, which is a closure. That's the closure with the config that I told you has all the information you want in there. And config.document is a view model for a document to open. So it handles opening the thing up, getting it out of the file, creating a view model, emoji art document, which is our view model, and handing it to us. So that all we need to do is say emoji art document view, here's my view model. Config.document. It's really cool at this level. That's all there is to that, what's going on. The blue thing is kind of interesting. That's a little closure that creates a new document. Because you're going to see when we look at the UI for this, that there is a button that says create me a new untitled document. And it's going to create it for you, and it's going to call this closure. And for us, that's easy. Just create one of our view models. And it'll automatically handle all the files. You don't do anything with the files here at the app level. You do a little bit of reading and writing in your view model, of course. But at this level, this is what the code looks like. And this code that you see looks like this for all document apps. It's just really simple like this. Now, you put this nice simple code in there, but then you have two things you have to do to make it all work. One is your view model, emoji art document, has to conform to this thing called reference file document, this protocol. And this is the protocol that makes it so the thing can be read and written to the disk. And it's a very simple protocol. We're going to learn all about that. And then the second thing is you have to implement undo. This might seem kind of weird. It's like, what does undo have to do with any of this? But undo is how the whole document system knows that this document got edited. If you did something that can be undone, then your document must have changed. And so I'm going to write it out to disk. And this document system auto-saves your document. It just automatically, anytime something changes, maybe not immediately, but very soon, it's going to write it out to disk. So that's why undo is important. And I think it's an interesting decision on their part to make undo be required. Because they could have put some little thing that says, oh, just mark this document as edited and then not have undo. But I think they wanted the experience for their users that apps with documents have undo. And so they just made it a requirement. So I kind of like it. And you're going to see it's quite easy to implement undo. So no problems there. Now let's talk about getting the view model to put your model on the disk and out. And we already saw this, right? We auto save our document, our one document. We know that we just have a data, we turn it into a JSON, we write it out to disk, we read it in. And it's very, very similar to that, but it's a little more formalized. So here is the reading from disk, and this is the init of your view model. So if you have a view model that is a reference file document here, you're going to have this init. And all this init needs to do is take this read configuration, and inside the read configuration, I think there's only two things in there, like the type of this file it is, like is it a JPEG file or whatever, and then this var called file. You see let data equal configuration dot file, and the file struct represents a file in the file system, and dot regular file contents means give me the contents of the file as a data. which is exactly what we want for us. It's going to be a JSON, encoded JSON. And then we just initialize our model. We're just going to say emoji art equals that thing from the JSON, and we're on our way. Notice that this thing throws. And if for some reason we can't get the regular file contents out of there, we're just going to throw this Cocoa error. Now, we could have made our own little enum for throwing there, file error or something like that. But I'm reusing Cocoa error here just because I think it's an interesting thing to be able to do. And if you go look in the documentation for Cocoa error, you'll see there's a whole bunch of Cocoa errors that are make a lot of sense that you might want to throw. It's just a convenient way to throw some common errors is to use a Cocoa error. Cocoa, by the way, is the name of iOS development system. It's called Cocoa. We don't really call it that anymore. Now we call it Swift UI. But so it's an ancient name, Cocoa. It's probably 20 years old. So that's how you read it in. Couldn't be easier, right? You just get the data out of the file there. How about writing it out? This one's a little bit odd. The function to write it out is called file wrapper. And the reason it's called file wrapper, and it returns a file wrapper, you see this type, file wrapper, is that some files historically in iOS, in Mac OS, they are stored as a directory with a bunch of files in there. So you could imagine that you had, I'm just making this up, this is not the way it's done, I don't know, but like pages, you have a pages document and it's got a lot of images in there. Maybe those images are stored as JPEG files in a directory, and the pages file is one of the files in the directory. You see what I'm saying? So we're kind of making it out of there. So that's what a file wrapper is supporting. But in our case with emoji art, we don't use any of that. We don't store our emoji art document in a directory with a lot of little files. We just store it as a data blob, right? Literally data. So if you're doing that, you can use this file wrapper constructor here, regular file with content, and you just give it a data and it makes one. But if you were doing all that weird directory stuff, you would do that in here, building your directory and putting your files in there. But all you have to do is return a file wrapper, and it will take that file wrapper and put it on disk for you. So this is essentially the writing. And this write configuration here, again, just a couple of things in there. It's got probably the type of file we're writing here. And so very simple. So that's the basics of reading and writing. Reading at the top, writing at the bottom. Now, there's a little more with reference file document though. Okay, reference file document, that previous one was just the basic reading and writing of file documents. This is specific to reference file document here. The most important difference is that the creation of the data that you're going to do happens in a separate thread in a reference file document in case it's expensive to create. It takes a long time maybe to create. It's some gigantic thing. Now in emoji art, totally not. Our emoji art documents are so trivial to create, we just JSON encode them, blam. But anyway, this infrastructure is built just in case. You have this func in the reference file document protocol called snapshot, and it passes the type of file. So like, is this an emoji art file that I'm asking you to snapshot, or a JPEG file, or what? And you give it back a snapshot. Now that snapshot, the blue up there, is a don't care, so you can do anything you want to give it back. Like you could give back an emoji art if you wanted, but usually we give back a data here, because eventually what's going to happen is we're going to be given that snapshot back on the main actor and asked to go write this snapshot out. This is where you put the thing that turns your model into a data when you're doing a reference file document. And then the file wrapper one that we saw on the previous page is a little different because look, they give you the snapshot back. So they're going to call the snapshot on a different thread. When it's done, they'll come back and call this file wrapper thing, just like we saw on the previous page, but with this extra argument snapshot. And then you're just going to write it out. And that's why it's nice if snapshot is a data, because file wrapper, regular file contents, wants a data as that argument there, right? So that's why a lot of times we'll make snapshot be of type data. But if it wasn't, if it was of type emoji art, which would be legal, then here we would be doing convert, right, do JSON, turn it, call the JSON function that throws, we'd be trying it, all that stuff. We could do that here. And that's all there is to doing reference file document. You implement this stuff, and these are mostly one-liners to implement, as you'll see when we do our emoji art. But inside there, you saw a lot of reference to types, the types of file, right? An emoji art file or a JPEG file. That is this type UT type, which is a uniform type identifier. And there's some infrastructure in Swift for dealing with these things. For standard files like JPEGs and things like that, the UT type struct has some statics, right? .jpeg, .text, .pdf, and you can use those for standard if you're reading and writing standard types. And why, by the way, would you do that? What if in emoji art we had a menu item, save as JPEG, where it would draw our thing as a JPEG? Well, then we might be writing JPEGs out. But if you have a custom type, which we do in emoji art, you have to invent your own one. And that requires doing some stuff in your project settings of your app to tell the system about this new custom type, emoji art type, that you have. And one of the most important pieces of it is you have to have a unique identifier for it that no one else would use for their type. And so that's why we always use reverse DNS notation here. So emoji art is going to be of type edu.stanford.cs193p.emoji art. I don't think anybody else is going to choose that for their type. And then we have to say what this means. And this is how we do it. This little screenshot here is from the project settings of the app. You'll see we're going to do this in the demo. It only wants a few pieces of information here. First of all, there's two different kinds of type identifiers. There's exported ones and imported ones. Exported ones are ones you own, like emoji art. It's like, this is my type and I defined it. It's my company in charge of it. You're exporting it to the world. Imported type is identifiers that you are willing to read, but you don't own. So you're willing to read this type and somehow display it on your app or something, but it's not yours. So that's just exported and imported. So here's the exported type identifier. It has a name, emoji art. That's just so then the UI user clicks on it, it'll say, oh, this is an emoji art file or whatever. Here's our identifier I talked about. Over here is the extension. So I'm going to have my files for emoji art to be .emoji art, just like .jpeg files say .jpeg. Ours are going to say .emoji art. And then finally, there's this conforms to down there. These uniform type identifiers have kind of an inheritance orientation to them. This is not object-oriented programming or anything like that, but they can inherit meaning. You can think of them as protocols in a way, but they're not protocols from other types. So here's two types, public.data and public.content, just like edu.stanford.cs193p.emoji art is a type, so is public.data and public.content. And those types, you would never open a file that's of type public.data. It's more like an abstract superclass for other types. And why do we conform to those two abstract types? Well, public.data just means it's a regular file on disk that has binary data in it. It's not a file wrapper or some kind of thing like that. And then public.content means the user perceives it as a document. They want to see it in their file system. When they browse around, they see it there. So we obviously conform to both of those. If you're doing some of this stuff, go look at UT type, its documentation. There's a whole description there of all the dozens, maybe over 100 different types, both the abstract ones and concrete ones, and you can see how it all works. But for us, it's pretty straightforward here. So that's how we describe our type identifier. But since we're inventing a new type, we also have to fill out another part of our project settings, which say, what is that type, that edu.stanford.cs193p? And all we have to do is give the name of it again. And here in handler rank, we're probably going to say owner. We're the owner of this document. Our app owns this document. We should be the first one who gets to open them, where we can edit them. And this part right here is just how the system knows that there's a new thing called emoji art. The other one was saying that we can open them and edit them. This is saying it exists. So we're just declaring it. One other thing that you're going to see when you do those previous two pages that I was talking about there, you're going to get a warning in your app that says, whoa, you define a document type, but you don't say how people find it and interact with it. And there's a couple of different options you can do there. You'll see them in the warning. But usually we're going to pick this one, supports document browser. We're going to set it to yes, and we're going to do this in our info.p list. I don't think we've had a chance to edit the info.p list in this. Of course, I know some of you are running across that in your final projects, but you'll see how it's done. It's essentially just this little kind of dictionary of information, and we're going to add this one, supports document browser, to it and set it to yes. And that's going to make it so that the system knows that this app is got a document that it can show in the Files app, for example, on iPad, or in the file system on the Mac. So we got the UT types declared in our info.p list. Now we need to define this emoji art type in our code. And the way we're going to do this is we're going to add an extension to UT type to give our own little static. Because I told you there was uttype.jpg and uttype.text. Well, now there's going to be uttype.emoji art because I'm going to add this little static let emoji art. And the way I created it is I say UT type that is exported as, because it's one of the exported type identifiers, right? And I give it that edu.stanford.cs193p.emoji art. And by the way, if you run your program and this string does not match what's in your info P list, you'll get a runtime error, which is cool. You get a little purple error. And that's it. So now we have invented a new type, emoji art. And we can use this type in our reference file document, all those implementations that we're asking for UT types. Now we can use this one. And one of the things in reference file document we have to put is what types we can read and write. It's just an array of UT types. And of course, in emoji art, we only have one. So it's an array of one thing in it, our emoji art types. By the way, you don't have to put both of these. If you put the readable one and it's a type you own, it's going to assume you can write it as well. So that is all there is to it. It's surprisingly little code, and you're going to see a massive amount of user interface that gets added to your app just because you can read and write documents. But as I said, if you don't do undo, none of it works. It'll never save your documents. You'll just sit there thinking your document has never been changed. And the way we do undo is with this object called a undo manager. And the undo manager, super simple. It basically just lets you register blocks of code to be able to undo other changes. Right? You just give it a closure and say, hey, I just did something. If you want to undo it, here's the closure that says how to undo it. This actually making things undoable, that code usually lives in your view model. And why do you think that is? Because that's where all your intents are. Right? You got your intents in your view model that say how the model gets changed, adding emojis, setting background. So that's where you're going to put the undo. Unfortunately, the undo manager comes to you on the view side. And in fact, the undo manager is just an @sign environment variable. Remember, @sign environment is not @sign environment object, different thing. @sign environment is just looking things up in that environment values place. And one of them is undo manager. And so you're going to put this at the top of some view or some views, and you're going to get the undo manager. You really have a choice here. You could get your undo manager and maybe on a peer of your view, you could give it to your view model. Say, here's the undo manager to use for all the intents. Or you can do what I'm going to do in this demo, which is every time you call an intent, you pass along the undo manager to use to undo it. I slightly prefer the other way, but I have definitely seen it done the first way, and the code's a little cleaner the first way, because in the second way, now all my calls to my intent functions, I have to add this extra argument. You'll see this in the demo, and you can kind of make your own decision which way you want to go there. You got this undo manager inside your intent function in your view model. How do you use it? Really easy. You call this function on the undo manager called register undo with target. The target is the object, in this case it's going to be our view model, that handles the undo, that figures out what to do with the undo. And then how to undo is just a little closure that takes the handler, that with target self, and hands it back to you and says, okay, you said that this was the thing to handle undo. Here it is. What is the code to undo this? And so that's what's in that closure. The how to undo is just a closure. Got code in it that says how to undo whatever you're registering. So that's what register undo does. You call register undo every single time you do something that can be undoable. If you have a view model whose model is just a struct, simple struct, then you can use this nice little code, undoably perform, that I wrote here, to make anything you do, any intent function, undoable. So let's walk through this. It's called undoably perform. Again, this is a function in your view model. And it has an argument, of course, with undo manager. And then the do it, that little closure there, is the thing you want to be undoable. So setting the background or adding an emoji, whatever it is, that's in this closure you're going to pass. Then all you do is you say, let old model equals model. And remember, our model is a struct. So when we say let old model equal model, what does it do? It copies it, right? Structs are value types. When you assign them, they copy it. So now old model is a copy of my model. Then I say do it, which is the set background or add emoji. And then I register the undo with the undo manager if I have one. That's what this question mark means. Could be nil. I'm allowing it to be nil up there. And inside the register undo, the closure I give is just set the model back to that old model that I just made a copy of. And that clearly is going to undo it. I'm going to go right back to the way it was. So these 4 lines of code inside here will make anything you do inside of a view model whose model is a struct undoable. Now, all you have to do then is wrap undoably perform with around all the things inside your intent functions. So you just go to every one of your intent functions and say undoably perform, wrap that around it. Undos can also be named, and this, a lot of times you just hit undo, you don't think about it, but most times in a Mac app, if you go up to the edit menu and look at undo, it doesn't just say undo. It'll say like undo set background or undo add emoji. The undo will kind of tell you what the action that you'll be undoing is. You can set that really easily by just saying undo manager set action name to set background or whatever you want, and it'll associate that action name with the register undo that's happening at the same time. And if you really want to be tricky, you see this myself.model equals old model right here? You could wrap that in an undoably perform, and then you'll get redo. So that's an easy way to get redo, one-liner. You can get redo, just wrap your undo inside that undoably perform. So that's it. That's all you need to know for the document stuff. I'm going to talk about this notifications thing a little bit on the side here. The idea of notifications is that you can asynchronously send little notices or notifications to other parts of your code. Now, this is not putting a notification to the user on screen, meeting at 5. Okay, that's a totally different thing. That's the UN notification thing, totally different, nothing to do with this. This is more something happens in the system and the system wants to send you a notification, this happened. So what kind of things might that be? Some database changed, like you're looking at the user's contacts and a contact got added or something changed about the contacts, and it's going to notify you, go look at those contacts again because something changed. Or the keyboard comes up. You know how when the keyboard comes up, it kind of pushes your UI out of the way? Well, you can actually find out where did the keyboard come up? What is the actual rectangle that it is, and when does it go away? So you can get notified about that. And there's other system settings, etc. Now, you can find out all the things that have these notifications from the system by looking at notification.name. And you can see there's hundreds of them. There's a ton of them in there. And you can find them other places too, like the one we're going to use actually, user defaults.did change notification. That's a notification that gets sent to you when someone puts anything in user defaults. And we need that for our emoji art because we rely on user defaults as our database for the palettes. You'll find them in both of these places. But one thing I'm going to caution you is that this whole notification thing is a little bit the old way of doing this. And really the number one way we do most of these things now is with @environment and the environment values. So if we want to know, we change from light mode to dark mode, we don't sign up for the notification that tells us that. We just do @environment. What mode are we in, light or dark? And it automatically redraws our views when that changes. And we want that kind of behavior, the automatic redraw and all that. So notifications is old world stuff. That's why I'm barely even wanting to show you. If I didn't have to do it for this user defaults thing for palettes, I wouldn't even show this to you. But go to environment values first to try and find what you want. And then if you really feel like you need to, you can start looking in notification.name and see if you can find some other notification that does what you want. And of course, you can make your own notifications and post your own notifications. So you can use the notification system to talk to your own code, other parts of your own code. But we rarely do that. It's really not. In Swift UI, because of the way it's architected as a reactive UI, you don't really need to do this. So how do you sign yourself up to receive these notifications when the system wants to notify you that user defaults changed? How do you sign up to find out? Well, in a view, it's really easy. You use this view modifier on receive. You say on receive notification center.default. The notification center is the thing that sends out these notifications for you. It's in charge of the notifications. And you get a publisher for the notification you're interested in, like user defaults.did change notification. That's what the blue thing is there. And then you just give it a closure and it'll execute that code whenever that notification gets sent. So again, if we're doing the user default one, anytime user defaults changes in any way, it's going to execute this closure. And you'll notice the closure has a little argument notification on it. I'm going to talk about what's in there in just a second. It's a really small little struct. But what if you're not in a view though? What if your view model wants to find out that user defaults changed, which is exactly what our case is? Well, it's a little more difficult then. You have to ask the notification center to tell you about it, and you do it by adding your closure using add observer, right? So you just say notification center.default add observer, give the name like user defaults did change or whatever. There's also these other two arguments, object and queue. The object is who's sending this notification. If you say a nil, then it means anybody who sends it. So a lot of times we'll put nil because we don't care who's sending it. We just want to find out when user defaults changes. And then queue, this is the old world of multi-threading, the queue system. Don't worry about it too much. We're always going to put main there because we want our code to run on the main actor. And it's talking about this closure down here. What queue is it going to run on? We want it on the main actor, so just say .main there. So here is the closure. This is exactly the same as the closure we had up there above. You can see it has the argument notification. And I told you I was going to tell you what was in it. Well, here's what's in it, this user info var. And this user info var is very unfortunately a dictionary where the keys are basically hashable things, hashable strings usually, and the values can be any's, right? They can be an any, which means you have to use as and is. Ugh, what a mess. Luckily, again, this stuff is old. We don't really do it much. This notification user info, for example, on the keyboard one, it's actually the CG rect is in this dictionary that tells you where the keyboard is now when it came up. It could be valuable. And notice also that this add observer returns a little observer thing of type NS object protocol right there. That's just a little cookie that you can use to later remove yourself as an observer. Because let's say your view model, like the user closes the window and the view model goes away. Well, you don't want to keep getting notified that the user defaults is changing, so it removes itself when it goes away. And you'll see that in the demo as well. And yeah, I put up a slide how you post your own notifications. It's notification center default.post. And this, as you imagine, there's the name that you made up, some notification name, and it sends, it's basically when you call this, it's going to execute those closures for all those other people who are at observering or on receiving. And that's about it. It's unfortunate that this user info requires the as or is, which we saw before. And anytime you see as or is, you're seeing an old API, right? We don't really do as or is anymore. We use protocols and we type things, but in the old world, we didn't have that. So we're stuck with any. All right, so that is it. Let's do a demo that shows all of this stuff I just showed you. We're going to do all of it. I'm going to start actually with, I like to do a couple little bonus things at the start that have nothing to do with what I'm talking about that day. The two things I'm going to do today is I'm going to send an app icon for my app, which please, all of you should do on your final projects. Okay, I want every single one of you to do it, and you're going to see it's so incredibly easy. There's zero excuse not to do it. Okay, so please do give your app an app icon. So how do we do it? Well, remember this assets down here. There was this app icon. You see there's this big space. It says 1024 by 1024. So you just put a very high resolution version of your application icon, and it'll scale it down to all the various sizes it needs, for document icons and all these things, spotlight results and all that. It'll do all that for you, which is kind of cool. In the old days, you actually had to provide about 30 different sizes, and now it'll do this for you. So I have an icon here. Here it is, my paint palette emoji. So I'm going to bring it over here, drop it in here. There it is. Now, this app icon would prevent me from ever shipping this app on the App Store, okay? And that is because I just screen grabbed the emoji for the paint palette. Now, it's really a good app icon for emoji art because it's an emoji of a paint palette, right? Get it? But this image was designed by some designer at Apple, and you're not allowed to use it as your own art. So this would immediately cause you to be rejected from the App Store. They wouldn't even get 2 minutes into running your app, and they would just reject this right away. What's the other little trick thing I was going to do? I will show you. It's here. Let's go up here and in document view. Let's run our app. We can see our nice new icon here. There it is. You see it down at the bottom? Watch this, though. I'm going to bring up my list. This is my list of palettes. I'm going to add another window, which is my settings app. So here's my settings app. And one thing you can do in settings is make your fonts in your app bigger. I think I mentioned this earlier in the quarter, right? I think I said old people like me, we can't see the really tiny fonts, so we want them to be bigger. So here is my settings app, and if you go, where is it in settings? See it now, I can't even see this is the problem, but I think here, accessibility, display and text size, larger font. Here we go. So you can navigate down here, and if you move this slider, it'll make your font bigger. So watch our app on the left as I change this in settings. Larger, see? Smaller, younger, older. Okay, so that's kind of cool. But do you notice something else? Look at our palettes at the bottom. They're not changing. You see the sports down there? I'm making it bigger and smaller, and it's changing these fonts, but it's not changing this down here. Why is that not changing? Why do these other things change and that one doesn't? Well, these other things change because they're using the body font, right? Font.body or font.caption or font.headline. All these built-in ones, those ones will automatically scale to whatever size this is saying. But what font do we use here? Let's go look at our code and see what font we use there. There it is right at the top, palette emoji size. It's .system 40. So it's fixed at 40, right? But there's a really cool little @ sign thing we can do. @ sign scaled metric var. And if we do that, it takes that 40 and scales it based on the font. So this scaled metric is only for things that are linked to font sizes, okay, content sizes. Let's run again. Add back our list. And here's our slider. Watch this. See? It's making it larger and smaller. Okay. Now, again, this is something that in the old world, we would have to get a notification, and we get the notification that this thing's changed, and then we'd have to redraw. Okay, so nowadays, no, we just @ sign scaled metric, all fixed. Okay, it's a good example of why we don't really use notifications anymore. Let's do emoji art documents. We're going to start by going to our project settings and inventing our new type, emoji art. So our project settings are up here. I think most of you are starting in your final projects to maybe go in here and have to do things. So we're going to do that as well. So here's our document type. We're going to add it, give it its name, emoji art, and its type edu.stanford.cs193p.emojiart, and its rank owner. And then down here in our exported type, we'll say that we can read and write this, emoji art, edu.stanford.cs193p.emojiart, public.content and public.data. And emoji art is his extension. Notice we can also add icons here if we want nice icons for our files. I believe actually what you really want to do for this is put a thumbnail of your document instead. And I'm not going to have time to show you how to do that, but there's a mechanism. It's, you know how you can quick look on files, right click on them on the Mac and say quick look, and it'll show you a quick look of it. That framework also has a mechanism where you can create thumbnails for files. So we would have to do a little bit of work in our emoji art, both our view model and our view, to create a little thumbnail, and then we could store that thumbnail in with our document. And then when users looked at our document, they would actually see a miniature version of it, which would be really cool. And that seems to be the way to do it. That is more helpful to users than just some generic icon that represents a document. And if you look at most Apple apps, that's what they do. They have a little kind of image of what the thing would look like. All right, so when we build now, we'll see this warning. You see it up there, this little one. If I click on that, it says here, this application supports opening files, but it doesn't declare whether it supports opening them in place, right? You can edit them in place. So you can set this document in place, or you can do supports the document browser, which is what we want. We want to be able to browse our file system and see our documents. And so I'm going to show you how to do that. I'm going to go back to my info.p list here, the same place where I just added this document type and exported type. I'm going to go up here to the bottom. I'm going to select one of them and right click and say add row. And that's going to add another row of info here. So all these, this is like a little dictionary, this info.p list with a lot of settings about your app. Now you can look at them and see what they are later. But we're going to add a new setting by saying add row. I'm going to scroll way down. What did it call it? Supports document browser or something. So it's under S. You can see it, a lot of things. Here it is, supports document browser. And I'm going to click this to be yes. So yes, we do support document browser. Now if I command B to build, that goes away. So this is the info.p list setup to make it so we have this emoji art document. And as soon as we install this on our simulator or on our device, now that device or that simulator knows that there's a type called emoji art. All right, now that we have that, we can actually go to our code and open and save these things. Let's go to, let's start in our view model. So here's our view model. And right now we autosave. Remember, we have all this autosave. I'm going to take all that out because we're not going to autosave anymore. Now we have documents. I'm not going to do this autosave, so let's delete that and delete all this and delete all this. We don't need any of that. It's all gone. See, we're not doing any autosaving anymore. Another thing I'm going to remove is over here in my emoji art app, just to clean things up. Remember, I had this palette manager code where I was taking over the whole screen and showing the palette manager so you could see the three-paned split view. Let's just get rid of all that. That was where we could see multiple stores. So this is more what our app would look like normally right here. All right, so where do we go from here? Well, to make our app go from being the kind of app it is now, which by the way, let's take a look and see what our app can do now. We haven't added the document support yet. Here's my app, and I can say add another window here, get a nice background, and I can add emojis on here. And I can also go up here and say add another window, and look what happens if I click on my own icon. Look, I get a second one. So now I actually have two windows here looking at the same document. You see this one and this one over here? Same thing, and they both have the truck. That's because both of those windows are looking at the same @state object here, this default emoji art document. Since they're seeing the same view model, they're showing you the same document. Now they each have their own zoom and pan because they are separate views, but they're both looking at the exact same document. So that's kind of neat that you could have multiple windows looking at the same document, but it's not as neat as being able to have multiple documents. So the first thing we're going to do is change our window group right here to be a document group. And this is the thing that's the base of all the document behavior. And you'll remember that this one had a little argument config, which is the configuration of it. And instead of using our default document that we have up here, instead we're just going to grab our view model out of that config. And then the other thing we're going to do is have another argument here, a new document, which has a little closure that creates a new document so that when the user says new document, they get it. And when I do this, there's two things. One, I can get rid of this default document because I'm not using that anymore. Now my document, my view model, is coming out of being created from these files, these document files. But you also see I got big old error here, a really important error. Let's look at it. Emoji art document needs to conform to reference file document. That's that whole protocol I was telling you about. And once we do that, we're going to have opening and closing documents. That's all we have to do. So let's go over to emoji art document and make it implement that. Here it is. Emoji art document currently implements observable objects, so we'll make it do reference file document as well. And if we click on reference file document actually to get the little documentation for it, you'll see that it's a protocol that inherits from observable object. So only observable objects, only view models, can be reference file documents. It also means we really don't need to save both of these things, because a reference file document is by definition also an observable object, inherits from that. Now, of course, we need to implement this protocol, so let's use our fix. Go up here, fix. Now we got some of our reference file document here, not all of it, right? We got the readable content types, that's nice. That's the thing that we're gonna fill out with emoji art. And we've got our init to open up a document, but we didn't get our saving ones, the file wrapper things. Where are those? Well, before it can generate those, it needs to know the type of your snapshot. You see the very first line, snapshot equals some type. And for us, I'm gonna have our snapshot be a data. Again, I could have my snapshot be an emoji art and convert it to a data later, but might as well do the JSON encoding in the snapshotting process in this other thread. Now, as soon as I do this data, now I'm going to get this error that I still don't conform. Let's fix again. Fix. Now I've got all of the functions, all 5 things here. You see, snapshot, file wrapper, the readable content types, the init, and then of course a little type alias for what type we are. By the way, once it generates this with this return value, you actually don't need this type alias anymore, because it can infer it from the snapshot's return type, that your snapshot is a data. What error we got here? Cannot find type UT type. That's this uniform type identifier. And to get that to work, we actually have to import our uniform type identifiers module. Okay, so don't forget that piece of it. You'll be kind of frustrated why it's not working if you don't import that. It's a different module there. So let's just go through all our errors here. What's this one? Static var declaration requires an initializer. Well, of course, we have the static var. It doesn't say what it's equal to. I'm just going to have it be computed right here. I'm going to return an array with what I want to say. Instead of JPEG or PDF or something like that, I want to say emoji art. Right? That's the content types that I want to be able to read and write, by the way. And of course, this doesn't work because it says UT type has no member emoji art. It has JPEG and PDF. No problem. Go up here, extension to UT type. And this is where we have this static let emoji art equal a UT type that is exported and uses that edu.stanford.cs193p.emoji art. So I've just added another static. And if we go, by the way, and look at UT type in the documentation, we can get a look at all the other ones we have here. You can see there's quite a few of them, different types. Look at them all. GIF files, GIF, JPEGs, MP3 files, MP4 video. So these are all well-known UT types, and we just added another one, emoji art. And our app is now also a well-known type. Look at that, no errors. So now all we have to do is fill out these little gray code blocks to implement the actual functions. And let's just start at the top and work our way down. The snapshot, really straightforward. We know how to do this. We need to return our model as a data. So that's just our emoji art as a JSON. And then it has a little error here, call can throw, but is not marked with try. Of course, we know that turning our emoji art into a JSON can throw. That's a throwable little function. So we'll just say try. By the way, we don't need return because this is a one-liner that returns this. That's it. What about this one, the file wrapper around here? Well, we have to create a file wrapper, and we write a regular file. So we're just going to return a file wrapper. And one of the ones down here, see it, regular file with contents instead of a directory with file wrappers. We just want a regular file with contents here. And the data that we're going to provide here is our snapshot, because our snapshot returns a data. And then it gets passed back to us here, and we're just going to create a regular file with it as our file wrapper. That also is a one-liner that can just be returned. Okay, this is pretty easy. What about this guy? So here we are creating a emoji art document, a view model, from this read configuration. Let's take a look at this read configuration that was given to us. File document read configuration. Look, only has two things. content type, which is UT type. So for us, that's always going to be emoji art. That's the only type we say we know how to open. So that's always going to be emoji art. And then it has this file, which is the file wrapper. If we look at file wrapper, it's got a whole bunch of stuff that has to do with doing the wrapped thing, directory of files. But if we look down here at the bottom, it's got the one we want, which is give me this file wrapper's regular file contents. That's the var we want. I'm going to use that. And here I'm going to say, if I can let data equal this configurations files regular file contents, then I'm going to create my emoji art document from it. And by the way, if it's not, then I'm going to throw that error, that Cocoa error that we saw on the slides. Go error dot, and you can see, look at all the different file errors that you could possibly throw with Cocoa errors, lots of different things. In this case, it's basically like a corrupt file. If we got this far, it must be corrupt or something. How else would we not be able to get the regular file contents? Because we're just asking for the data. And if we have that data, it's JSON data for emoji art. How do we create it? I'm just going to set my emoji art model equal to an emoji art from that JSON. And of course, this can throw as well. So let's try. And you can see that these things rethrow. So I don't have to do catch or try question mark or anything. It'll just rethrow it up out to the document system or whatever. Voila, that is it. Really 4 lines of code that actually do anything to make our app readable and writable. Let's go take a look. Our app looks completely different. We just run our app, no palette across the bottom. What's going on here? Instead, we're getting this nice, essentially, document UI for managing all of our documents. And look at that, create document. I told you we were going to have a UI for creating document. Also look along the left. Here we can browse documents on my iPad here. Here's my emoji art document directory. Go inside here, and that's where it's going to put all those. But I could also be saving my files on iCloud Drive. I don't have my simulator signed into iCloud here, so I'm not seeing it, but I can save it on iCloud just as easily as I can on the local file system. So let's go ahead and create a document here. Here it is. Let's add a background to it. Here. All right, got a nice background. Add another truck out here. And then we go back here. And there it is. And uh-oh, that's a little scary. It says down there 31 bytes. I don't think that's big enough to describe that URL and that little truck. And in fact, yes, if I open it again, I lost everything. Why? No undo. No undo means no document saving, right? So we got to go back and implement undo to make this all work. Now, how are we going to do undo here? I'm going to do that trick I told you before about the undoably perform. I'm going to put it down here in my intents. Because almost always, all of your undo code is in your view model's intent area. That's why we segregate it out like this, and give it a nice space so that we always know where we're going, where things might be undoable. So let's put this little private func undoably perform, and it needs an undo manager to do its work. Undo manager, and I'm going to make it default to nil. So if you say undoably perform and you don't provide an undo manager, it does it without undo. You basically can't do undo. And then we need a do it, the actual thing to do. Put that right here. And inside here, we're going to do this trick that I showed you. Since our model, our emoji art, is a struct, a value type, we can do this thing where I say let my old emoji art equal my current emoji art, then do it to change my model in some way, and then have the undo manager, if we have one, register for undo. And the target here is myself, and the handler is going to pass myself back to me. That's what this argument to the handler is whatever this target is, it gets thrown back to you later when you're undoing. And we can do trailing closure notation here. And inside here, if I'm trying to undo it, I'm just going to have myself's emoji art equal the old emoji art. And hopefully you all are comfortable with this idea of how closures capture the state outside of them, right? So old emoji art is a local variable, and this closure captures it and actually keeps it in that closure in the heap, just waiting for someday later when the undo happens. And then it can use this local variable inside the closure. That's kind of why we call these closures. It creates a closure of all of the named things that are around when the closure is declared like this. And if you don't really understand what I'm saying there, you want to go back to your reading and reread the section on closures. If we want to be nice undo, we could do a name for this, for each of our undo things. So maybe we have something here, action, which is a string. And then when we're registering, we'll do undo manager, set action name to be that action so that we can get undo paste, undo copy, undo add emoji, undo set background. We'll get the actual word for it. And heck, while we're here, let's do redo as well. And all we need to do redo is wrap this in an undoably perform. So I'm going to have myself do an undoably perform with that same action and with the same undo manager. And all we're going to do for the do it is to do this. All right? So redo is just undoing an undo. That's what redo means. So we have this great undoably perform. All we need to do now is go and put it in all of our intent functions. So for set background right here, that's a good one. Let's do it here, undoably perform. And the action here would be set background with some undo manager. And where's this undo manager coming from? Well, like I said, we can pass it as an argument here, maybe undo with undo manager. Or we could hand it off from our view to our view model at some point, hopefully before any of these undoable things happen, right? Maybe on a peer of our view or something like that. But again, I'm going to pass it in separately to all of them. And in fact, I did that for all of these other ones just to speed things up. All these other intent functions, you see all these? I have a little underbar undoable intents that are exact same thing. I haven't changed anything except I put an undo manager argument and I do undoably perform around each of them. And I even kind of put nice names on them, like when you add an emoji, it'll actually, you know, if you say add a helicopter, it'll have add helicopter. So when you say undo, it's going to say undo add helicopter, which is kind of cool. Now, this has made it so that our view model is entirely undoable. But our view, of course, has to provide the undo manager. So we got to go change all the places we call our intent functions here. In my version of the app here, it's only set background and add emoji. In your apps, it's more resize, move. You have other intent functions that you called because of your homework. I'm just going to go back to my emoji art document view and go down to our drag and drop. Here it is. This is where we set our background. I'm just going to say undo with the undo manager, and same thing with our add emoji. Undo with undo manager. And where do we get this? This we get out of that environment. So if we go up here, add sign environment / undo manager, var undo manager. I can't remember what we really showed these @ environment things, but if you option click on it, you'll see a description of @ environment, and you see where it says environment values right here. Let's go ahead and look at that. So here's all the many @ environment things you can do to find out what's going on in your app. You can see there's quite a lot about what's happening in your display, what's happening with scrolling or state. You can find out things happening with your scenes, all kinds of stuff here. And this is really the new way of finding out what's going on in your system, as I said, not that notification way. All right, so let's run, see if this works. All right, bring this guy up. Let's go add another window. Let's drag this out. Okay, maybe we'll zoom out a little bit. Let's get a Is that a taxi cab? I can hardly even see it. Something like that. And back. And how many bytes does it say now? Oh, is that 300? 238. Oh, that looks good. It looks like it might have saved that file. Let's go look. Voila, it saved it. And we can do another window here. Let's go add another window. And again, I'm going to click on my own icon to get one here. Create a new document. I called it Untitled 2 in this case. Let's go get this different background. Zoom out a little bit. Let's put it maybe a good place for a helicopter, one of my favorite emojis. It's right here. Of course, I have to zoom in and out when I drag and drop them because I don't have resize like you guys have. We have two documents right here, this one and this one. And we can go back here and, for example, rename these by pressing and holding. See, you press and hold, say rename. This one, taxi. And then press and hold on this one. Rename, I can't even say it, there it is. This is, we'll say helicopter. Now there's one last thing I'm going to do, which is to add an undo button. Because we have this nice undo where we can put things here and undo, but how do I do undo? I don't have any UI. So let's put a little undo button. I'm going to go back to my document view here. I'm going to put it right here. I'm going to say toolbar, add a little toolbar along the top, and I have undo button. And I wrote the code for this undo button. I'm going to put it in my extensions over here under our undo button. It's really quite a simple little button. If you tap on it, it does undo. If you long press on it, then it shows this popover, and this popover will show you the undo option if you have it, or redo if you have redo. So you tap to undo, you long press if you want to do redo, basically. So let's see this in action. So dot toolbar, did we see dot toolbar before? I think we might have. Dot toolbar. Dot toolbar adds these buttons along the top. I think we did do it. Yeah, when we did the plus button, right? In the palette list, we did a toolbar button. So there it is up there. That's the undo button up there. If I drag something out, like let's put a golf course right here and hit undo, whew, it went away. And now if I press and hold, there's redo. I can put it back. And if I add a couple more golf holes out here, actually let's add hockey goals instead. Hockey goal, stopping people on the road there. Now, when I press and hold over here, I'm going to see undo the hockey goal. And if I undo that, now I have the choice to undo the golf thing or redo the hockey goal. All right. So this I'm showing you on iPad. We don't have our Mac version of this, but on the Mac version, you'd look in the edit menu and it would be showing you undo and redo like this. And you see why it says undo the golf course, right? Because back here, in my emoji art document, when I did my undoably perform and add emoji, I said add emoji. I put the actual emoji that I added, and that's why I'm seeing it over here. This is almost working. We definitely have multiple documents. We can kind of open them in different windows, etc. But there is one kind of weird thing. Watch this. Look at my palettes down here. Whoa. Okay, I'm sweeping through my palettes. It's changing it in both windows. I don't think that's what I want. Because one document I might be, doing some COVID thing or something, and the other document I'm doing vehicles like this. So I want them to be separate. So why are they staying the same? Well, they're staying the same because in our app, we made our palette store be global to our whole app. So all the scenes are getting the same palette store. So when you change the cursor index, it's changing then in all of them. So that's not what we want. How do we fix that? Easy. We're just going to get rid of this here, and we're going to put it down into the views. So each view here is going to have its own palette store. Now, I'm going to rename this shared to make it clear that they're all still sharing the same backing store. They're all sharing the same user default. It's the user default with the name shared now. And so any changes we make to the palettes are going to affect all of them, but it's just that cursor index that we're clicking through is going to be different for each of them. So this is kind of almost the perfect situation where we're sharing the palettes among all our scenes, but each has their own little cursor index. So let's see this in action. Oh, got an error here. Why do we have an error? Well, because I was injecting my palette store from the app level all the way down. So now I want this injection to happen in each view, because each view has its own palette store, but it still wants to inject it down into all of the palette choosers and all that. Okay, here we go. Ready? Woo! It's separate. Over here. Separate. What about if I delete one over here? I deleted it here. It's gone. Is it gone over here? Yeah, no more animal faces. However, we got a little bit of one problem left, which is this. So you got animals on both sides. Watch this. Delete. Oh, it didn't delete the animals on the other side. You see? So I got animals over here. What's going on? We know they're sharing the same backing store, and in fact they are, because animals is going to be deleted here the next time this palette store looks in the user defaults. In fact, watch, if I start cycling around, it's gone. It's just that it didn't instantaneously delete it because it didn't notice the change in user defaults. So that's where this notification thing comes in. We're going to add the notification. Let's go over to our palette store. And when we initialize it, when we first create our palette store, we're going to ask that notification center, please notify me if user defaults changes. So we just say notification center.default, add observer. We want this one down here. Put this little space in here so you can see these arguments better. There. So the queue, we want the main queue, of course. Object, we don't care, anybody who sends it to us. And the notification we're interested in is user defaults.didChange notification. And then inside here, we're going to get this notification passed to us so we can look at its user info, but we don't care. We don't care what the user info is. And what are we going to do when user defaults changes? Our palette store, kind of like its underlying backing store changed, we want our views to update. Well, how do we make views update? Object will change.send. This is an observable object. The object will change.send says, go make the views update because I've changed in some way. Now it's interesting here that we have an error. This is something you're not going to see a lot in value programming. In fact, you'll never see it in value programming. This only has to do with reference types like classes. And what it's saying here is the reference to object will change in this closure requires you to explicitly use self. In other words, it explicitly wants me to say self.object will change. Why does it want me to be explicit there? Because this closure right here is going to capture self. So that closure sits in the heap. The notification center is holding on to it, just waiting for the notification to happen so it can call that closure. And that closure has a pointer to this palette store inside of it. It needs that pointer so that it can send object will change, right? Well, that has got some problems going on because that is going to keep this palette store in memory forever. Until we remove observer, right? We never remove ourselves as observer, then we are always going to have this palette store in memory. So that is a problem, and we're going to fix that in a second here. There's a couple of ways to do this. If we took this out, another fix that is offered to us, I'll show you. If I hit here and hit fix, it says capture self explicitly. Okay, we did this one reference self explicitly, but we could capture self explicitly like this. And it put a little square bracket self. Do you see it right there? And this is a little notation. This is not an array or anything. This is just listing things to capture in order to make that closure work. So we're explicitly saying, I know I'm capturing self there. So that when I use self inside, when I do object will change, we know it's captured. And we're going to use this to our advantage in a second here because there's going to be a problem with this. Now notice I'm also not getting the little cookie and removing this observer. And I want to do that, but let's just make sure this works first, and then we'll go back and do that. All right, here we go again. We get another window. This guy, this one. Here we go. Now, we got vehicles in both. Ready? Here we go. Delete. Woohoo! It deleted it in both, and this object will change.send, and it updated the UI. So that did fix it. But like I said, we have a little bit of a problem, and it's this. I want to do this thing where I say observer equals this, and then I have a little @ state private var, which is that observer, which is this NS object protocol weird thing. Then I want to remove it. So I added it. When do I want to remove it? I want to remove it when this palette store disappears. When this window is closed and we're not looking at this document anymore, I don't want to watch that user defaults change. So there's actually a cool little function only on reference types called dinit. It's like the opposite of init. This gets called when you leave the heap. Okay? When no one else is pointing to you anymore, you get thrown out of the heap, this gets called. Perfect time for me to say if let observer, then notification center .default remove observer, that observer. And I'm going to put a little print in here so we can see that this is working. Remove observer. Let's go over here, run, and open this, and add a window, this one. Now, when I close this window, when I hit close, over here, we should get something in our console, right, that says remove observer, shouldn't we? Because it's going to get deinitted. So let's see. Close. Over here. Oh, some things happened, but no, I don't see remove observer here. Never got called. Why is this? This is because that dinit never gets called because this palette store never leaves the heap because that closure always keeps it in the heap. Right? That closure up here, this one right here, it captures self, so there's no way for the palette store to ever leave the heap as things are currently designed. And that's not good. How do we fix that? Well, there's a really cool thing we can do here and say, make this a weak self. Weak self means don't keep this thing in the heap. And if no one else is interested in it, then just set this self to be nil. So it turns self into an optional that no longer keeps that thing in the heap. And now we have to say, since it's an optional, we have to say self ? Dot object will change because it might be set to nil. So this weak self gives the opportunity for the thing to be removed from the heap, out from under this closure. And we're being safe here in that when the closure does run later, if it were ever to be called later after we've left the heap, that will be nil, and so nothing bad will happen. Be cool? Now if we run, close this, go back here. Aha, remove observer. It actually did remove the observer. Yeah, that's good. So that last little piece that I'm telling here about this, we used to have to worry about this all the time because we didn't use value types in the old UI kit world. So we were constantly having this problem where things were being kept in the heap and we had to weak self and make sure they're. Now we hardly ever have to do that because almost everything's a value type. So you don't have this problem with the value type because the value types aren't in the heap. So how could they possibly be kept in the heap? This is not even an issue for them. Okay, perfect timing, right on time today. And if you have any questions, say, and oh, by the way, if you haven't hooked up your device to this in preparation for next week to just test it, please do that now.